Hello, good evening everyone. So in today's class, we will see a new course that is known as Geotechnical Engineering Laboratory. It is a very important course with respect to civil engineering because whenever you construct any structure, the type of soil to be used is very important. So in this course, we will study the different types of soil and how the basic properties of soil are determined using laboratory equipments. So I'm sharing the screen. I hope it is visible to you. If not, you let me know. So this normally it is a course in the fifth semester in most of the universities, and credits allotted for it is two. So what are the course objective of this lab? To carry out laboratory tests and to identify soil as per IS codal provisions, to perform laboratory tests to determine index property of soil, and also to perform tests to determine shear strength and consolidation characteristic of soil. So the models include field identification of soil, specific gravity test, this specific gravity test is again further divided into pycnometer and density bottle method. Next is water content determination by oven drying and pycnometer method, rapid moisture meter method, etc. The grain size analysis, two methods are there, CO analysis method and hydrometer method. Apart from that, in situ density test are there. First is core cutter method, next is sand replacement method. Apart from that, consistency limit such as liquid limit test is used, which is calculated by using Casagrande and cone penetration method. Next, plastic limit test, shrinkage limit test. Apart from that, standard compaction test is also there for light and heavy compaction. Coefficient of permeability test is also there. Constant head test or variable head test. Shear strength test, unconfined compression test, direct shear test, triaxial test, unconsolidated undrained test only. Next, consolidation test to determine pre-consolidation pressure only half an hour per loading test. Laboratory vane shear test. Apart from there are some demonstration of soil pressure test, standard penetration test, and boring equipment. The textbook used for this is PC Purmia, Soil Mechanics and Foundation Engineering, 16th edition by Lakshmi Publications. Apart from that, Lambert TW Soil Testing for Engineers by Willy International Limited can also be referred. Reference book includes Head KH Manual of Soil Laboratory and Bose Engineering Properties of Soil Properties. So, what are the outcomes of this course? After the successful completion of this course, the students will be able to draw the particle size distribution curve and to find the particle size, to find the maximum dry density and optimum moisture content, to find the CBR of the soil, to find the SBC of the soil, to find the consistency limits of soil. So, what are the things the student should be careful while carrying out this laboratory? That is included in the rules. Bring observation notebooks, lab manuals, and other necessary things for the class. Use tools for mixing concrete and water. Check the instruments for proper working condition while taking and returning the same. Throughout, clean your laboratory workspace at the end of laboratory session. Maintain silence and clean environment in the labs. So what are the things you should avoid? Do not operate the machines without the permission of the staff. Do not put hands on it while equipment is in running condition. Do not fix or remove the test specimen while the main is switch on. Do not spill the concrete and aggregates on the floor. So are some about some what precautions you need to take while carrying out the laboratory test. Apart from that, what are the different types of test? The first test is determination of specific variety of soil solids by Pycnometer method. Second method includes determination of specific gravity of soil solid by density bottle method. The third method is density determination of water content of soil solids by oven drying method. The fourth method is experiment is determination of water content of soil solids by Pycnometer method. The fifth method includes determination of in situ density by core cutter method. Sixth is determination of in situ density by sand replacement method. Seventh is determination of particle size distribution by sieving. Eighth is determination of liquid limit of soil by Casagrande apparatus. Ninth, determination of plastic limit of soil. 10th, determination of shrinkage limit of soil. 11th, determination of maximum dry density and optimum moisture content by standard Proctor compaction method. 12th is demonstration of coefficient probability by constant head method. 13th is determination of coefficient of probability by variable head method. Next is determination of liquid low limit of soil by cone penetration method. Next, demonstration of shear parameters by direct shear test. Next, demonstration of unconfined compressive strength of soil. Demonstration of vane shear test. Demonstration of swell pressure test, standard penetration, and boring test. So depending upon the availability of your labs, you can carry out the various experiments. Remaining experiments can be kept as for demonstration purpose only, if it is not in working condition. So the first experiment which we are going to study today is determination of specific gravity of soil solids by Pycnometer method. See here, this is a very interesting course, but whenever I explain you after going to your college, you can ask your sir who is taking geotechnical lab. At that time, it will be very helpful for you because it is a practical oriented course. Unless and until you perform in the lab, then only you will understand the things. Aim to determine the specific gravity of soil solids by Pycnometer bottle method. So before what is the aim of this experiment? We need to determine the specific gravity of soil solids by using Pycnometer bottle method. Now comes the question, what do you mean by specific gravity? Specific gravity is the ratio of mass of unit volume of soil at a stated temperature to the mass of the same volume of gas-free distilled water at a stated temperature. So how you are defining specific gravity? A ratio of mass of unit volume of soil. We are assuming the mass of unit volume soil as 1 kg. If it is a soil of 1 kg, the ratio of mass of unit of volume soil at a stated temperature, say room temperature or say 30 degrees Celsius, to the mass of same volume of gas-free distilled water at a stated temperature. So, mass of unit mass of water at a given temperature to the same mass of water at a which is free from gas-free distilled water at a stated temperature. It is known as specific gravity. So, what are the specifications? This test is specified in IS 2720 Part 4 1985. A soil specific gravity largely depends on density of minerals making up the individual soil particles. However, as a general guide, some typical values of specific gravity soil types are as follows. So, specification this for performing this test, you can use IS code 2720 Part 4 1985. The specific gravity of soil largely depends on the density of the minerals making up the individual soil particles. However, as a general guide, what you can do, you can classify the specific gravity into different types. The specific gravity of the solid substance of most organic soil varies from 2.6 and 2.8. Suppose fine aggregate, coarse aggregate also specific gravity varies from 2.6 to 2.8 only. Tropical iron-rich laterite as well as some laterite soils usually have a specific gravity of 2.7 and 3, but could be higher. What is happening? Suppose tropical iron-rich laterite and laterites, if they contain more amount of iron, then they are termed as lateritic soils. They usually have a specific gravity between 2.7 and 3, but could be higher. Sand particle composed of quartz having a specific gravity ranging from 2.6 to 2.67. So, soil, what is the specific gravity of sand particle? 2.65 to 2.67. Inorganic clays generally range from 2.7 to 2.8, whereas inorganic clays value specific gravity varies from 2.7 to 2.8. Soils with large amount of organic matter or porous material such as diatomaceous earth have specific gravity below 2.6. Some range as low as 2. See here in the specification what we need to understand which code is used for determining specific gravity. IS code IS 2720 part 4. Apart from that, specific gravity of standard material. For example, inorganic soils are there. So its specific gravity ranges from 2.6 to 2.8. Similarly, tropical iron-rich laterite is there. Its specific gravity varies from 2.75 to 3. Inorganic sand particle composed of quartz have a specific gravity from 2.65 to 2.67. And inorganic clay specific gravity varies from 2.7 to 2.8. And soils with large amount of organic matter or porous material, their specific gravity is even below 2.6. Some range as low as 2. So it is a type of Viva questions only, specific gravity or standard soils. Now, what are the equipments required in this experiment? Pycnometer of about 1 liter capacity, balance accurate to 1 gram, glass rod, D8 distilled water. So not much instruments are used, only pycnometer, about 1 liter capacity, glass jar, a ball balance accurate to 1 gram, D8 distilled water. Now, theory of specific gravity. So the specific gravity of a soil solids is defined as the weight of soil solids to the equal volume to the weight of equal volume of water. As I have stated earlier also, how you are defining specific gravity, weight of water, weight of soil solids to the weight, same weight of soil solids in equal volume of water. In effect, it tells how much heavier or lighter the material is than water. This method covers the determination of specific of solids passing through 4.75 mm sieve. So equation for specific gravity is G equal to W2 minus W1 divided by W2 minus W1 minus W3 minus W4. Now comes the question, what is W1, what is W2, what is W3, and what is W4. Equation you have to remember while solving the problems or even by carrying out the experiment. Once again, G equal to W2 minus W1 divided by W2 minus W1 minus W3 minus W4. So what is W1? Weight of pycnometer in grams. Next, W2 weight of pycnometer plus dry soil in grams. W1 is weight of pycnometer in grams. W2 is weight of pycnometer plus dry soil in grams. And W3 is weight of pycnometer plus soil plus water in grams. W4 is weight of pycnometer plus water in grams. This method is recommended for coarse and fine grained soil. So what are the precautions you need to take while carrying out this experiment? Soil grains whose specific gravity is to be determined should be completely dry. So dry soil should be used for experiment. If on drying soil lumps are found, they should be broken into its original size. If lumps are there, they should be broken to in original size. Inaccuracies in weighing and failure to complement element entered are the main source of error. Both should be avoided. Why it should be done? In order to avoid errors. While cleaning the glass jar, please be careful as there may be glass grains projecting out and it may tear the skin. So it is not possible. Generally, it will not happen. Make sure you handle the glass jar and conical cap without falling on your legs or floor. Hence, handle the equipment with care. So it is precaution. Prevention is better than care. Now, what is the procedure? First is clean and dry the pycnometer and weigh it along with the conical cap W1 in gram. So first step is you have to clean the pycnometer, dry it, and along with the cone, you have to weigh it. That will be weight of the empty pycnometer. It is termed as W1 in grams. Next, select about 300 gram of dry soil free of clots and put the same into pycnometer. Weigh it as W2 in gram with cap and washer. So what is W1? Weight of pycnometer with washer or conical cap. Next, what you have to do? 300 gram of dry soil which is free from lumps. You have to insert it in the jar and again you have to weight it with conical cap. That will be W2. Now fill the pycnometer with de-add water up to half its height and stir the mix with the glass rod. So now what you have to do, you have to add water up to how much point? Such that the pycnometer is half filled and you have to stir with the help of glass rod. Add more water and stir it. fill the screw cap and fill the pycnometer flush with the hole in the conical cap and take the weight W3 in gram. So what is W1, W2, W3? Once again, I am telling you, just listen it. W1 is weight of pycnometer with cap. W2 is weight of pycnometer with cap plus 300 gram of dry soil. In the third case, what you are doing, you are adding amount of water up to half. So the pycnometer is filled. That will be your and steering it with the help of glass rod. And again, you are adding water up to the top. That will be your W3 in gram. Finally, remove the all the contents from the pycnometer, clean it thoroughly, and fill it with distilled water. Now, what you have to do, you have to completely remove the soil, water, everything from the pycnometer. Only pycnometer you have to fill completely with water. That weight you call it as W4 in grams. Now use the above equation for determining G. That is G equal to W2 minus W1 divided by W2 minus W1 minus W3 minus W4. Now, what are the questions which are likely to be taken into account or asked during the Viva? So, pre-Viva question is why we need to compute the specific gravity of soil? What is the purpose of calculating specific gravity of soil? Next, what is the unit of specific gravity? Number three, what is the specific gravity of water? Fourth, explain the steps to determine specific gravity of pycnometer method. Fifth is what are the calculations required in computing specific gravity by pycnometer method. So why we need to compute a specific gravity of soil? In order to determine the property of it. Because suppose as I said you, specific gravity of different soil is different. Fine aggregate may have different specific gravity. Similarly, coarse aggregate may also have different specific gravity. So based on specific gravity, you can classify the different types of aggregate. Next, what is the unit of specific gravity? So it is the most likelihood questions that many of the examiners ask you unit of specific gravity because there is no specific unit for specific gravity. It is a unitless quantity. What is specific gravity of water? Specific gravity of water is 1. Explain the steps required to determine specific gravity by pycnometer method. So steps just now we have seen, that is first step is you have to take the pycnometer, wash it carefully and dry it and take its weight along with the cap, that will be W1. After that, you have to fill 300 gram of soil which is free from lumps and you have to weigh it, that will be W2. Next, you have to add water up to the top along with the soil. Along with the cap, you have to measure the pycnometer, that will be W3. Finally, you have to remove all the things and you have to insert the water completely such that the pycnometer is completely full, that will be W4. So your G, that is specific gravity, is given by W2 minus W1 divided by W2 minus W1 minus W3 minus W4. So what are the calculations required in computing specific gravity of pycnometer? These are the calculations. That is how to calculate W1, how to calculate W2, how to calculate W3, and how to calculate W4. So tabular column, if you see, serial number, particulars, test number 2, test number 3. Normally what we will do is 3 times we will conduct the same experiment and we will take the average of it. Weight of pycnometer bottle W1 gram. In grams, we are calculating all the values. Weight of pycnometer plus dry soil, that will be W2. Weight of pycnometer plus soil plus water, W3. Fourth is weight of pycnometer plus water. It is included with conical flask or cap. Calculation of extension integrity G is equal to G1 plus G2 plus G3 by 3. Because we are taking 3 readings, we are dividing by 3. If you are taking 2 readings, you have to divide by 2. Now, specimen calculation. What is the uh, formula to calculate specific gravity? G is equal to W2 minus W1 divided by W2 minus W1 minus W3 minus W4. Because it is the first experiment, you may not get confused. But as you continue, you go on conducting the experiment, this type of formulas will be very confusing. So, how to remember this? A trick I will give you. G is equal to 21 divided by 21 minus 34. That is 21 is nothing but W2 minus W1. Similarly, 21 minus 34 is 3 minus 4. So using that, you can easily calculate the G. The value of specific gravity for the existing soil falls in the range of 2.6 to 2.75. 2.6 to 2.75. The value of specific gravity. The value of specific gravity. Hmm. The value of specific gravity for the existing soils falls in the range of 2.6 to 2.75. If there is any validation, check under the specification provided and redo the experiment to get accurate result. See here, normally the value of specific gravity of most of the soils falls between 2.6 to 2.75. If there is any variation, you can once again carry out the experiment and come to a conclusion. The experiment is conducted as per the procedure laid down in the specific gravity of soil. Solid is obtained as whatever it may be, you can write. This value falls in the range of 2.6 to 2.75. Hence, this type of soil is you have to classify whether it is soft soil, hard soil. You can, depending upon the values obtained, you can classify the soil. So, what are the post viva questions? Number one, what are the standard values of specific gravity? So when we say what are the standard values of specific gravity, normally it ranges from 2.6 to 2.75. But what you have to do is you have to remember this is what that is which is given in specification. What was given in specification? The specific gravity of solid substances of most inorganic soils ranges between 2.6 and 2.8. If it is inorganic soil, whatever it may be, into value specific gravity ranges from 2.6 to 2.8. If it is tropical iron rich laterite as well as some lateral soils, they usually have a specific gravity of 2.75 and 3 and could be higher. For example, cement it is there, its specific gravity is 3.15. So if it is tropical iron rich laterite, its value ranges from specific gravity value ranges from 2.75 and 3. Sand particles composed of quartz having specific gravity ranging from 2.65 to 2.67. Normally, specific gravity of sand is 2.65 only. If it contains quartz, its value may increase to 2.67. Inorganic clays generally range from 2.7 to 2.8. If it is inorganic clays and even if it is a coarse aggregate, its specific gravity value is from 2.7 to 2.8. Soils with large amount of organic matter. If suppose soil is there, if it contains more amount of organic matter, its specific value decreases to 2.6, and even some soils have specific gravity of less than as low as 2. So these standard values you have to remember. If it is somewhat confusing, you can remember that the specific gravity value ranges from 2.6 to 2.7 in most of the cases. Do we need to conduct this test? Why? Yes, we need to conduct this test. The reason being different types of soils have different specific gravity, and depending upon the specific gravity, you can classify them. And whenever you construct any structure, you will have an idea whether what type of soil it is and what is the safe bearing capacity of soil, whether it can withstand the load, whether it can be used for earthquake resistant structure, which type of foundation it is. So all that things, soil properties are important. So this test is very important with regard to soil classification and also for construction purpose. What is your inference on the result obtained? See here, there may be some error. There may be some trial and error, but most of the times you will get a good results in when you carry out a specific gravity test because there is not much confusion. It is simple. It is W1 is weight of empty pycnometer with cap. W2 is weight of pycnometer with cap plus 300 gram of soil. After that, what you have to do, you have to completely fill the water up to the top. That weight you have to take, that will be W3. Finally, you have to remove everything. You have to again weight, that will be W4. And if you use the formula G equal to W2 minus W1 divided by W2 minus W1 minus W3 minus W4, you will easily get the specific gravity value. So there is not much confusion in it. So our inference and the result obtained is almost correct. Even though if you are getting some error, you can once again carry out the test. Can we use this method for all types of soil? Yes, you can. No, not sure because in the next experiment only we are studying about a specific gravity by some other method. So there are different methods. So different types of soil we can use different method. So it is somewhat confusing. Write phase diagram for dry soil, saturated soil. See, phase diagram is nothing but normally soil is classified as a three-phase system consisting of water, air, and solid. This you have studied in geotechnical engineering also. Using that, you can draw the phase diagram for dry soil and saturated soil. Dry soil, it will not contain water, while a saturated soil, it will contain water. So phase diagram will be changed. In case of saturated soil, you will have water, air, and solid. In case of dry soil, you will have air and solids only. So in the next class, we will see experiment determination of specific gravity of soil solid by density bottle method. It is also very good experiment, but before going forward, because time is also less, I will just recall the things. After that, we can wind up. First is we need to understand what is the lab all about. Geotechnical engineering lab. It is one of the important labs of civil engineering. So, what is the purpose of keeping this lab? What is the objective of this lab? To carry out laboratory tests and to identify soil as per IS for permission, to perform laboratory tests to determine index properties of soil. Index property of soil may be liquid limit, plastic limit, shrinkage limit, cohesion, adhesion, capillarity, surface tension. To perform tests to determine shear strength and consolidation characteristics of soil. So as we move forward, we will calculate what is the shear strength of soil, what is the what you can say consolidation characteristics of soil, or that also we will study. So after studying what is the outcome of this course, that is also very important. So after the end of this lab, we will be able to draw the particle size distribution curve and to find the particle size. And apart from that, we will be able to find the maximum dry density and optimum moisture content. Apart from that, to find the CBR, California bearing ratio of the soil, to find the safe bearing capacity of the soil, to find the consistency limit of the soil. So consistency limit include liquid limit, plastic limit, shrinkage limit, and all. So apart from that, we need to take some precautions while doing the lab, such as not to operate the machines without the permission of the staff, not to put the hands while equipment is running condition, do not fix or remove the test position while the main is switch on, do not spill the concrete and aggregate on the floor. So what are the things the students should do? They should bring the record books to the and come on time to the labs, use tools for mixing concrete and water, check the instrument for proper working condition while taking it in the same, or else they will be held responsible for any damage caused. Though thoroughly clean your laboratory workspace at the end of the laboratory session, and also maintain silence and clean environment in the lab. So the first experiment was specific gravity of soil solids by Pycnometer method. In short, I will tell you what you know specific gravity, weight of solids, unit weight of solid at a given temperature to the same weight of solid measured with respect to water. That is known as specific gravity of soil. It is unitless quantity. Its value ranges from 2.6 to almost 3. But normally for solid substance such as inorganic solid value varies from 2.6 and 2.8. For iron rich laterite it value varies from 2.7 and 3 and can be higher up to 3.15 for cement. For sand particle it is 2.65 to 2.67. For inorganic clays it is 2.7 to 2.8. For soils with large amount of organic matter, it highly greater is its value decreases. Soils within organic matter is value decreases and it is below 2.67 to 2. Now, what is the formula to calculate G? G is nothing but W2 minus W1 divided by W2 minus W1 minus W3 minus W4. So, what is W1, W2, W3, and W4? W or W1 is weight of water, W2. Okay, so this concludes our topic for the day.